So this video is about lecture 5. So in this video, I will talk about two basic elements of circuit, that is inductor and capacitor. So both of them are two terminal devices. So at first, let's look at inductor. So we use inductor to store current in the circuit. So the behavior of inductor is actually to oppose the change of electrical current. And this inductor composed of a coil wire wound around a maybe a magnetic material or a non-magnetic material. So when a wire is bonded around this non-magnetic or magnetic material, and when current passes through it, so it makes a magnetic field that are around there and store the electricity inside that wound. And the source of magnetic field is charge in motion or current. So when we have moving current or moving charge, then there will be magnetic field will be created around there. And and this is the notation of inductor, this winding, and we denote inductor as capital L. And inductor follows the Faraday's law. The first Faraday's law is whenever a conductor is placed in a varying magnetic field and electromotive force is induced. So what is electromotive force or EMF? So it's basically the voltage. So when I have uh, let's say I have a circuit with just a simple um, copper wire, and I have a steady magnetic field. When I move that circuit to the magnetic field and out of the magnetic field. Yeah, if you attach a emitter in series with that circuit, you will see that the current is getting generated. So this is the Faraday's first law of electromagnetic induction. And second law is the induced EMF. The induced voltage in a coil is equal to the rate of change of flux linkage. So what is happening over there? So magnetic field has magnetic flux. When I break the magnetic flux, voltage or EMF is created. So the total induced voltage is equal to the N is the number of turns, and this P is actually the magnetic flux. So this delta P is actually the rate of change of magnetic flux with respect to time change. And as the inductor opposes the change of current, so voltage across this inductor will be L times ddt of I. So inductor opposes the change of current. So in this circuit, I have the varying current, that means the AC current source of I over here, with and I have an inductor of 100 millihenry over here. So L is always a constant. L is constant. And how I get current from this equation? I will get current from this equation just by one-step integration. So when I do that, so I will solve this problem in class later on. So, and this will be the current equation, just the integration of voltage. And IT0 is the initial current. Is the initial current and 1 by L. So this L is the inductor value over here. So for this circuit, this is 100 millihenry. So this problem I will solve it in class later on. So if what will be the power around the inductor? If I apply P equals VI equation and I put the value of V in V, and I put the value of V is L times ddt of I times I. So this is my power equation over here. And what will be the energy equation? So we know that power is equal to ddt of energy, this W. So how I will get this W? by integration. So if I integrate this whole part over here with respect to t, as this is ddt or ddt, if differentiate with respect to t, then we will get this whole power, not the derivative energy. We will get the whole energy, and that is if we do the integration, and that will be just like this half Li square. So this is the energy inside the inductor, and this problem I will solve it in class later on. And let's talk about capacitor. So we use capacitor to store charge in a circuit, and capacitor opposes the change of charge in the circuit. And capacitor generates the electric field, where inductor generates the magnetic field. So this is the symbol of capacitor. This is the positive plate of the capacitor, and this is the bent one is the negative plate of the capacitor. So how capacitor works? When I pass current through this capacitor, the positive charge will be gathered around the positive plate of the capacitor, and negative charge will be gathered around the negative plate of the capacitor. And here, electric field will be generated, and electric field will be generated. So when other charge will come, that charge will pass through this electric field. So in this way, the capacitor works. So what will happen? Capacitor has the limit of charge actually. Say for example, I have 10-volt battery is connected across this capacitor. So when current passes inside this capacitor, the charge equal to the 10 volt will be stored around here. And when this capacitor charge collects the charge of 10 volt, then it will discharge the whole 10 volt charge during this direction. So in this way, capacitor will charge and discharge with respect to time, and this time is called the time constant. So time constant defines how much time it will take to discharge this charge. Same goes for the inductor also. How much time it will take to discharge the field current. So that's called discharge the current. That's called the time constant. And in capacitor, the current equation is I equals C times ddt of V. Ddt of V. And what will be the voltage equation for the capacitor? So that will be just the integration of that current equation. I will integrate this part around here. So I over C, I will integrate this part over here, and this V is VT0 is the initial voltage stored initially across the capacitor. Sometimes we have there will be question with the initial voltage, and sometimes there will be question without the initial voltage. And power equation is I just put the value of I in the equation equal VI, and I get the power equation. And from there, I derive the energy equation, which is this half CV square. I just integrate this part over here, and that will be half CV square. I just integrate just V. So when I integrate V, and then this ddt will cancel with the integration. Then I left with the integration of V. So integration of V is V square over 2. So the whole equation is a half CV square. So this problem I will solve in the class. Now let's talk about the combination of series parallel of inductor and capacitor. And inductor behave as a resistor. So when inductor is series, it will behave as a series connection of resistors. So this is the series equation, so series connection equation for inductor. And for parallel connection, same as the parallel equation of the resistor. This is just like this. And for the case of capacitor, that is opposite. capacitor in series will actually behave as the resistor in parallel, and capacitor in parallel will behave as a resistor in series. So these are the series and parallel connection of capacitor and inductor, and this is the basically basic difference between capacitor and inductor. The main difference is inductor store current and capacitor store charge, and others we talk about that. So next is mutual inductance. So before we move to mutual inductance, we have to solve this equation to understand, solve this problem to understand the capacitor and voltage equation and all other basic steps. So we will talk about mutual inductance in later class. So after solving this problem, so this video ended over here. Thanks for your patience.